Welcome to a hands-on journey into production-grade Cosmos blockchains. We'll connect Cosmos SDK, CometBFT, and ABCI++, so you can reason about custom modules, consensus hooks, trade-offs, and operations like someone building real networks. The path is step-by-step. Cosmos and CometBFT foundations first, then SDK application development, then the ABCI++ consensus lifecycle, and finally token, IBC, and operational concerns. Each stage builds the confidence needed for the next. As the course develops, we'll build in layers: the Cosmos ecosystem, SDK app design, and ABCI++ internals. By the end, those ideas will connect to production concerns like assets, interoperability, validators, and day-to-day operations. Treat this course as a working practice environment, not just a set of explanations. If you're new to Cosmos, start at the beginning and protect the foundations. If you're intermediate, stay sequential, but slow down around modules and ABCI++. If you're advanced, use lessons as a reference. Then verify assumptions in code. Run examples, review notes, diagram flows, test edge cases, and ask questions with the version, error, expected behavior, and what you tried. Let's start by building the map. Cosmos is not one blockchain. It is an ecosystem of sovereign chains that can connect and exchange data through IBC. Some chains act as hubs, others as zones, but each keeps its own application and governance. Under the hood, a Cosmos SDK chain separates custom business logic from networking, consensus, and the ABCI++ boundary. Once that structure is clear, the rest of the module has a place to fit. Cosmos starts from a different assumption. Not every application should compete for space on one shared chain. A DeFi app, a game, and a privacy protocol may need different rules, fees, validators, and upgrade processes. Cosmos lets each become its own sovereign chain, optimized locally. The key point is that sovereignty does not mean isolation. Through interoperability, these chains can still move tokens, messages, and data across the wider network. Think of Cosmos as a network of sovereign chains. Each zone runs its own validators, applications, and state, so it keeps independence. A hub focuses on connectivity, helping zones reach one another without every chain needing direct links to every other chain. Underneath that model, IBC provides the shared communication standard. It lets compatible chains send packets, move tokens, and pass application messages securely. Cosmos Hub is important, but Cosmos is not limited to one hub. Cosmos favors app-specific chains because some products need more than smart contracts on shared block space. Instead of competing with unrelated apps, a team can build its rules, fees, modules, and governance directly into the chain. That can improve performance and user experience. But it also adds responsibility: validator coordination, security assumptions, upgrades, and operations. So the trade-off is flexibility and control versus the simplicity of shared infrastructure. A Cosmos chain is easier to understand when you separate responsibilities. The networking layer keeps nodes connected, gossips transactions, and propagates blocks. CometBFT is where validators agree on the next block and give it finality. The Cosmos SDK application defines what those transactions actually mean: messages, modules, state changes, and business rules. ABCI and the newer ABCI++ form the contract between consensus and application, so each layer can evolve without mixing concerns. As a Cosmos SDK developer, most of your custom code lives in modules. Messages define what users can do. Keepers protect access to state. Query services expose reads, and Genesis logic sets initial conditions. App wiring connects those pieces so they behave as one chain, while the state database persists the results. ABCI++ is the advanced edge. Use it when block proposals, validation, or consensus-adjacent data need application-level control. Not every app needs that depth. Zooming in, a Cosmos SDK app is a collection of specialized modules. Each module owns one domain, like staking, governance, transfers, or custom logic. Users express intent through messages, and those messages are handled by module code that uses keepers to read or update state. Keepers are the safety boundary. They control what can touch the store. Queries follow a similar path, but they only read state instead of changing it. Cosmos separates actions that change state from actions that only read state. A transaction is the write path. It packages messages, signatures, fees, and metadata, then routes each message to the right message server. That server checks intent and uses keepers to update the store. Queries take the safer read path. Query services expose current state through gRPC, REST, or CLI, so external apps can inspect data without modifying the chain. Now let's follow a transaction through the system. It starts with a user's signature, then moves into a node's mempool. Gossip spreads it across peers, so validators see roughly the same pending work. When it is time to create a block, CometBFT selects a proposer, and that proposer packages transactions into a candidate block. The Cosmos SDK application validates and executes them. Once consensus finalizes the result, the new state is committed. In Cosmos, technical architecture quickly becomes product strategy. A DeFi chain may need modules for custom assets, liquidity, and IBC routing. A game chain may care more about throughput, latency, and predictable fees. An Oracle or data chain might push specialized metadata closer to consensus with ABCI++. The design question is always about trade-offs. What stays sovereign, what connects interoperably, and what creates operational cost. Good chain design starts by matching architecture to the product's real job. You now have the core map. Cosmos connects sovereign zones through IBC. Each chain separates application, consensus, and networking. The SDK structures application state and logic, and CometBFT reaches agreement. Next, we focus on ABCI, then ABCI++, the interface that lets these layers work together.